All right, so this section is going to be pretty pivotal in what we do beyond this. What we've been doing so far, chapters 1, 2, and 3, are kind of clarifying some things that we're going to use kind of periodically through the next 5, 6, 7 chapters. But those 5, 6, 7 chapters kind of start with having an understanding of what we do in chapter 4. Okay, so a lot of stuff that we do early on here is going to be very useful to you throughout the rest of the course. So my hope is that we learn this quick and that we're able to understand it, have a good understanding of it, and a good grasp of it. It doesn't cause any issues later on. In the past, I've gone pretty quick over this stuff, and that has been kind of detrimental to the group. Okay, so I want to make sure that we go through this relatively slow, pick up on it, and then as we start to pick up on it, increase the pace. But today we're talking about 4.1 is congruent figures, and essentially this whole chapter is about triangles, except for this section. Okay, this section is going to just be kind of a generalization of all shapes in regards to congruency, and then we'll pick up tomorrow and the next day with just focusing on triangles. There is vocab in this chapter. I wouldn't say there's as much as there is in other chapters, but there is quite a bit when we start talking about isosceles triangles and equilateral triangles, that kind of stuff later on. Just kind of rehash, you don't necessarily need to write this down, but remembering that congruent figures are figures that have the same size, the same shape. We have talked about segments and angles. Those are the only shapes we've talked about so far. Now we're going to start composing them, putting them together, and 3 angles and 3 segments are going to get a triangle. Okay, so understanding the relationships between triangles and other triangles, and then we'll do it with quadrilaterals and compare those to other quadrilaterals and stuff like that. Yes?
Why is your desk?
Because I want it to be. Because I want it to be. All right. So the way the number one component to what we talk about today and how we deal with this stuff is this second bullet here, and it says the way we name congruent figures is going to be extremely important. Okay. The name should tell you everything that you need to know. The way you end up writing congruencies with shapes tells you everything that a picture would tell you. All right. Some problems are going to have a picture and the congruency, and that's really nice. That's the kind of optimal situation that you would want for these types of problems. But some will say, "Oh, we're just going to give you the picture," and you have to develop the phrase, the congruency statement, is what we end up calling it. But you have to develop that on your own. Okay. Some give you the statement, and you have to develop a picture. Okay. So 3 different little styles of problems that you'll see, or pieces of information that can give you. The optimal is that they give you the picture and the statement together, but they don't always do that. So hopefully, gaining and understanding what we're going through here today, they can give us a minimal amount of information. We were able to do everything that we need to do with that little piece. So it's important that you name them correctly. All right. If you do not name them correctly, you will struggle for the rest of the year. Okay? Yes.
I don't like my seat.
I don't care.
Roasted.
All right, so here's the idea. All right, and I want to kind of fix this. I didn't mess around with it last year, but I didn't change it back. So, all right. So if I look at these 2 shapes, okay, our task, our goal here is to take those 2 shapes and figure out what parts correspond, okay? And much like we talked about correspond in chapter 3, talking about corresponding angles for lines, for 2 lines being cut by a transversal, we're talking about corresponding and kind of the same idea, but now not instead of looking at lines, now we're looking at triangles. So we're looking at corresponding parts. And corresponding throughout the whole course, all it means is matching position or matching location. Okay. So if I look at these 2 shapes, let's see if I can group these real quick. This example is pretty easy, but we'll alter it in a moment and show you how they vary the difficulty with these things and where people get themselves into trouble. We want to match. We want to see what corresponds, and really corresponding means what matches to what lands on top of what. When I merge those two figures together. So hopefully you recognize. If I just talk about segments right now, that when I move these two on top of one another, the AC land underneath, or I guess we can do it this way: XZ is XZ land on top of AC.
Yes.
Does that make sense? Okay. So what that means to us is those two segments are corresponding. They're matching parts or matching positions. Does that kind of make sense, everybody? So that is one argument we want to make. We want to say that in regards to sides that correspond, we want to say here AC corresponds to XZ. And I'm just going to use that arrow to show correspond. All right. If I look at AB, okay, what is AB going to correspond to? I corresponds to AB, right? You won't really take your hands off.
No, it's illegal.
It would be illegal.
Scared me.
But quit doing it. So AB,
You didn't hear what we were talking about?
no, AB corresponds to XY. Would you guys agree with that? They overlap?
Yep.
Okay. And what would be the last segments then? Let's talk about AC and AB so far.
Y. YZ.
Charlie?
BC and YC.
Okay, yes. So both are right. BC and YZ. Okay. That's pretty easy to see what matches there, right? Okay. Now here's the issue. People want to only do that. They only want to say, okay, I'm going to match basically left segment, bottom segment, right segment, right?
Yeah.
And if it's just a pure, you guys remember from 8th grade math or 7th grade math, that what this is called when I just take an image and I,
Slide it.
yeah, that's what they call it. They call them the slides, okay? It's really called a translation. The math word is translation. But when that it happens to get from one figure to the next, it's really easy to say bottom to bottom, right to right, top to top, that kind of stuff.
Aren't the other two have reflection?
Yes, but we could have reflections, we could have rotation, okay? And that becomes a problem if you're a person that just focuses on matching left to left, right to right, bottom to bottom, that kind of
Line of symmetry.
stuff. So,
Ten sign.
once I find sides that correspond, it's going to be a little bit easier to find the angle. So let's say I look at angle A, all right? And I want to figure out what A corresponds to. And again, most people are going to say, well, it overlaps on X, right? Would you guys agree with that?
Yeah.
The best way, though, to make that distinction is to look at angle A and think about the types of segments that make it. And what I mean by types, I look at this one and say, that segment and that segment make angle A, okay?
True story.
All right? So they have, what I mean by types, that one has 3 marks in it and one has 1 mark in it, right? So it should only correspond then to an angle over here that is created by a segment that has 3 marks and a segment that has 1 mark. So identify those segments and then I trace them back to where they converge, where they meet, and that meeting is at angle X, right, or vertex X. Does that kind of make sense? All right. So A corresponds to X. Now, what would B correspond to?
Equal Y.
Okay, and if we look again,
Wait, it's angle, right?
yeah, angle. Angle B is made by 3 and 2, right?
Yeah.
Side with 3 marks and side with 2 marks. So over here, I got to find the side with 3 marks, side with 2 marks, and then Y corresponds with B. And then the last ones are C and Z, right?
Yeah.
Once you find the 2 that correspond, the third ones are there by default.
I do that weird marking with Z, man.
Huh? So people don't, sometimes my Z's look like 2's. All right, so here's the issue. That is pretty easy when it's just a translation, but you guys said we have reflections, we have rotations, right? So let's say that I had a picture that looked like this.
Oh.
I know the letters are upside down, all that kind of stuff.
Rotation.
If I did a reflection there, let's say I do one more. Let's say I go that way. Okay? So, what just happened?
You
I
did
did
it.
another one, right? All right, don't worry.
Uh,
All right.
It's called rotation.
So now, if I look at, maybe top angle to top angle, people are going to say C and Y, right? Well, do C and Y, do they overlap if I do that?
Oh.
No, they're not the same angle, right? Can't do that. But we still want to come up with an idea of what corresponds to what. So again, if I'm looking at angles, let's say I want to look at angle C and what it corresponds to. It is created by a segment that has 2 marks and a segment that has 1 mark, right? Z, trace those back to C. All right. Now I come over here and 2 and 1, and you tell me what?
Z.
Yeah, it creates angle Z, so C and Z correspond. And that's exactly what we had previously, right? So that should still be maintained, still the same triangle, just been moved around a little bit. Is that okay?
Yeah.
So make sure that you understand when it's appropriate to kind of use the shortcut of what, left side compared to left side, right side compared to right side, that kind of thing. Or when you need to do that practice we just did right there. Okay. If we go to the next slide, it's going to bring in the definition of what congruent figures are. Okay. And really, talk about polygon. We haven't identified a polygon yet. But a polygon, okay, just meaning by definition, poly means many, and gon means angles. So many angles. So it's a shape of many angles. And then we'll talk about how to classify polygons, all that kind of stuff later on. But we're basically looking at triangles now, looking at quadrilaterals, looking at pentagons, those types of things. Okay? A lot of times called closed figures. Right? So a definition for congruent polygons is simply polygons that are congruent have corresponding parts that are congruent. Okay? Corresponding just meaning matching. Is that all right, everybody? If I look at those two shapes up there, okay, hopefully you realize it's not simply a, left angle to left angle, right?
Yeah.
I can't say A and F the same, because obviously they don't land on each other, correct? There's a reflection occurring here that's important for us to recognize. But what they're saying here with this key concept is, if I know that these two shapes are congruent, okay, so I could go through a process where I take those two shapes. So this one here was the ABCD, what I did earlier, I guess. We have that. We'll start with that picture there, right?
Yeah.
Okay. So if they're congruent, we should be able to reorientate them, and one should land on top of the other, right? That's the idea of congruency.
It doesn't.
Okay.
Yeah, it's just.
All right. So you see then that A needs to match or correspond to what angle?
E.
E. A and E have to match up. B has to correspond to what angle?
F.
F. C needs to correspond to what angle? G, and D needs to go to H. Okay? So when we specify a congruency, this statement here needs to tell me exactly the same thing the picture told me. Does that make sense? So when I write that, and I can name A, B, C, D any way I want to. Okay? They just put them in order, they're alphabetical. Once I say A, B, C, D is congruent to E, F, G, H, what I gain from that is everything that the picture provides. Angle A, because it's the first letter inside that name, should correspond to E, or angle E, because it's the first letter in the second name. Does that make sense, everybody?
Yeah.
We look at those, A, go back to the other picture, A, E, they overlap each other. Okay? Likewise, B is the second letter in the first name. So F is the second letter in the second name, and they need to be corresponding parts, B and F. Is that doable? All right. So then you see that C and G need to match up, and D and H need to match up. And if they are congruent polygons, then those corresponding parts, corresponding means first and first, second and second, third and third, and then fourth and fourth. That's what we mean by corresponding. Does that make sense? If the figures were congruent and their corresponding parts were congruent. Good question? With congruencies, okay, when they provide me this information, we should be able to pick out the angles that are congruent to which angles. We should also be able to do the same thing with segments. Okay? If I look at these first two letters, okay, does that trace out a segment up here, AB?
Yeah.
Okay. And if I look at the next two letters in the second name, E and F, does that trace out the corresponding segment if we were to overlap those two polygons? Yeah. So what we say then is that, and you see it up here, AB is congruent to EF. All right. And then we go to the next set, or next pair of segment or points, I guess, and they're B and C. And B and C traces out another segment. So what do you think B and C should correspond to in the other picture?
F and G.
F and G. Okay. And if we highlight those, it is F and G. Okay. That makes sense picture-wise, right? And then we got C and D, which is going to be this last segment on the bottom, or a third segment on the bottom, and that should match up with, so C and D, last two letters here, G and H, last two letters there, should match up with G and H. And it does visually, right? Okay. Now, we've only traced out 3 segments in this figure and 3 segments in this one, right? So the remaining figures, the remaining segments that must be congruent are AD and EH, right?
Yeah.
Look at how they are put together over here. AD is the first and last letters, and EH is the first and last letters. And that's the one that, when I ask for congruencies, a lot of times people miss. Because as we're doing that, as we're going through and naming a figure, we always start at vertex. And we start moving to the next vertex, either clockwise or counterclockwise, doesn't matter, until I get back to what I started with. So if I go A to B to C to D, and then that gets me back to A, and getting back to A will then close that figure off in that last segment. So same thing, A, B, C to D, and then E, F, G, H. EH will be that last segment over here. Now here's the thing. I don't need to name it that way. Let's say I call this first polygon D, C, B, A. The way we name it's important. We can't skip letters, okay? So I can't go from like D to B to A to C, because the order that I write them should trace out the exact picture that I want. If I want D to B to A to C, that picture there is not a polygon. Does that make sense? So I want to go D to C to B to A, and now give me back to D, and now I trace out that exact polygon. But now think about how that should match up over here. Okay? Once I determine how I name the first one, that dictates how I name the second one. So D, this angle D, matched up with H, right? Okay? D up here and H over there, the last term. Now I rewrote D first. So I better rewrite H first. Does that kind of make sense?
Yeah.
All right. C then, over here was my third letter, and G was my third letter. So C and G always need to be matched up. Okay. B goes with F. Okay, so I'll put F. And then again, A matches up with E. So I renamed it. Basically, I just flipped it, right? A, B, C, D, and I went D, C, B, A. So if this was E, F, G, it needs to be flipped as well and go H, G, F, E. Does that kind of make sense to everyone?
Yeah. Yeah.
All right. If I mistakenly flip-flop these and I put E and then F there, okay? What I'm telling everybody then, if I'm telling everybody that's a true congruency statement, I've just told you that picture-wise, angle A better be the same thing as angle F. And we know that's not happening in the picture, right? So these two things, the picture and the statement, have to mimic one another, okay? They have to say the exact same information. It's not too bad with a pure translation like we did in that first question on the last slide. But what happens is we get pictures like this one here. Okay? And people want to say, well, angle H is the same thing as angle M. And then other people say, well, angle H is the same thing as angle L. Because they look like they should be the same angles, right? They should look like they should match up. For instance, if I look at angle J, what angle do you think J should match up to?
N.
N, okay? You could probably make that clarification, that assumption pretty easily and be right. But if I look at H, there's two possibilities. It could be L, it could be M. All right? And then I'm on a 50-50 guess and probably guess wrong maybe. But if I look at the congruency statement that they provide me with, the congruency statement that they provide me with, right here it says, the highlighter out here, that congruency statement right there tells me I know H should match up to what angle?
L.
L. So H and L are congruent. Okay? I should know I matches up to what?
N.
I and M go together. And then J is
N.
N, so that kind of verified our initial assumption about J and N, right? And then the last one would be K and O match up. That kind of makes sense? All right. But here's where this stuff kind of comes into play. They're going to tell me eventually that you have this congruency, you have this picture over here, but now they tell me angle H is like an expression. They'll say it's maybe 2x plus 5. And now tell me angle L is 60, and maybe they tell me angle M is 50. Okay? Well, in order to solve for x, I got to know what that angle h is equal to, right? So it makes sense, hopefully, that I first have to find that angle h, based off of our naming up here, is the same thing as L, right? So h is congruent to L. So now we set up the equation 2x plus 5 is equal to 60, correct?
Yes.
If I didn't do that, some people would say 2x plus 5 equals 50. That 50 is just there to throw you off. All right? We have to make this the conclusion of congruence by looking at this statement here. That's called a congruency statement that allows us to relate the correct parts to one another. Okay? So, no.
Oh, dang.
You don't need to write this down, but talking about congruent figures, we've talked about it means same size, same shape, right?
Yes.
So the size is, I was talking about the shape, but the shape is dictated by how many angles you have. 3 angles is a triangle, 4 angles, quadrilateral, 5 angles, pentagon, that kind of thing, right? Okay. The length of the sides, or the length of the segments then dictate the size. Okay? You know, how big is that shape? Okay? So when we say same size, same shape, those two components are dictated by separate things. Okay? So that's something to keep in mind as we go through some of the questions in a little bit. I'll put this one on here because I just want you guys to get used to like the end of course exam type stuff when they're going to ask you, can you justify your answers? We look at this and when you answer the question yes or no, are these two triangles congruent? Right now, the only way that we can show two shapes congruent, the only way you can show two shapes congruent is if you show all their corresponding parts congruent. Okay? So we got to find their matching parts and say that their matching parts are all congruent. So right now what I have to do is I have to show 3 angles congruent to 3 angles, and I have to show 3 sides congruent to 3 sides. Okay? So I got to show 6 things. Let's go through angles first. What is angle A congruent to?
E.
Okay, so angle A, I don't have a congruency symbol, but I'll use my equal symbol. Angle A is congruent to angle E. Okay, what about angle B?
D.
Okay, so that's pretty easy, right? And
It's equal. Equal. There you go.
there we go. All right, so A to E and B to D. Now, what's the third grouping of angles?
C to C.
Okay, be careful with how you name that, though. So if I say C to C, is that angle, that's the C you're thinking about, right?
Yeah.
And that's the other one, right?
Yeah.
But I have to make sure that I say it correctly to anybody that's reading this, because somebody might be able to say that that blue angle is also C. Or that blue angle is also C. Or that angle is C. So that linear pair collectively 180 degrees is C, right? So what would be a better way of naming that angle?
Unknown.
Huh?
Unknown.
Not unknown. The safest thing to do always when you're naming angles is to use 3 letters.
ICA.
Okay, so
BCD.
good. BCA.
That's wrong.
Hold on, I don't know what's going on here. All right, BCA. And you said what else?
BCD.
ECD is fine. I'm going to do it this way because this is something that's going to be useful for you to recognize. Just in general, naming figures from your. I started at B and went to C and then went to A inside that name right there, right? How many marks did B have in it? 2. So when you name the other angle, come over here and start where you've got 2 marks. So DCE. Okay. Now it doesn't matter that you do that in this situation, but if you can program yourself to think that way, that's going to help you a lot later on.
Go in front of that D.
You don't like the space there? Sorry. Okay, so now we've shown 3 angles congruent to 3 angles, right?
Yes.
Why were those angles BCA and DCE congruent?
Because they're the exact same.
Why?
Because the lines on the lines. The segments. The lines supposed to be right.
No. What types of angles are they?
Oh.
They're vertical angles. Okay, so the thing that's part of justify your answer, guys. If I don't write that on the end of course exam, they're not going to give me full credit. They're not going to give me those points. Okay, so I got to justify why those 2 angles were congruent. The other ones were congruent because they were provided, right? They were given. That's explicit. Okay. Now, what about AB? What segment is AB going to be equal to?
ED,
ED. What about BC?
C, DB, DC,
DC. That's fine. And what about AC?
A, EC.
EC. Okay. So AB congruent to DE. This first congruency, we were able to recognize that because the markings, right? And then these two were congruent because you're able to recognize that the lengths were the same, right?
Yes.
Okay, 4 and 4, and then 6 and 6 respectively. Okay, so justify my answer. These two triangles are congruent. If I spell it right.
Yeah.
Because it is shown
In the line.
that all three sets of corresponding angles are congruent, and all three sets of corresponding segments are congruent. Okay? That would gain you, if this is a 2-point question on the end of course exam, that would gain you both points. Okay? If I just say yes or I just say no, that might gain me 1 point or no points. I have to justify my answer. You have to answer it. Okay? And answer it in the methods or the formats that they're asking for. Okay? And they'll give you a space to type stuff in. Okay? And you can put all your thoughts down that way. All right, so when we get to this, okay, we should be able to, if I give you these two triangles, triangle FAT and triangle DOG, and I tell you they're congruent, what is angle F congruent to?
D.
Angle D. What's angle A congruent to?
Oh.
Angle O. What's angle T congruent to? Angle G, okay? That's pretty easy, right? That tells us that F corresponding to D, A corresponding to O, T corresponding to G, okay? Now, because the triangles were congruent, not only do those parts correspond, but they correspond and they're congruent. So F is congruent to D. Angle A is congruent to angle O. Angle T is congruent to angle G. Does that make sense?
Yep.
And then we do the same thing with the segments. FA goes to
DO.
DO, AT goes to
OG.
OG, and FT goes to
D.
DG. Okay? And those segments are corresponding segments, so they would be congruent, right? Right. So that idea, if I give you the congruency statement, that's what that triangle FAT, congruent to triangle DOG is called a congruency statement. You're able to show me what parts are corresponding, and then from that you can tell me what parts are congruent. That leads us to this phrase here. Okay, now it's a long wordy thing that nobody ever likes to say out loud several times. So we say the phrase is corresponding parts
Of congruent triangles are
of congruent triangles are congruent. So corresponding parts mean matching parts, right? Parts that lay on top of one another. Okay? Of two triangles that are congruent. So the triangles we start with have to be congruent. So matching parts that come from triangles that are congruent, those matching parts are also congruent. Does that make sense?
Yeah.
Okay? Now, corresponding parts of congruent triangles are congruent. That's a mouthful. It's very, especially when you want to say it over and over and over in a class or you got to write it out. You don't want to write that out. Okay? So use the acronym CPCTC. Okay? CPCTC. The only thing that I want you to make sure of is you understand that the C's don't represent the same word. A lot of times throughout the course, I get people say corresponding parts, corresponding triangles, and corresponding. Well, you didn't say a single thing there. Okay? Or they'll say congruent parts, congruent triangles are congruent. You didn't say a single thing that is new information. Does that kind of make sense? Corresponding parts of congruent triangles are congruent. That is new information. Okay? If I say corresponding parts, corresponding triangles are corresponding. One, I don't know what corresponding triangles are. Okay? But it's kind of redundant. Okay, it doesn't say anything useful over and over. Okay. But CPCTC, and that will be something we'll come back to, but that is a very critical phrase that's going to be used over and over. Math Excel, we use CPCTC. Sometimes it'll also use like CPOCTAC. We'll actually give of and R letters in that phrase. So you might see variations of it, but that's the gist of the thing. Okay. I want to go down to do a couple examples here, and then set you off on your own. All right. So here's the question. It says using properties of congruent figures.
What's the C stand for again?
Which one? Which one?
So we've got this picture, and I think I got it better over here, yeah. Okay. So they give me a picture, and they also give me a congruency statement, right? And then I start plugging in values and expressions for these things, and I should be able to come up with an argument that tells me what X is and tells me what Y is, okay? But I look at, let's just say we try to focus and find out what X is first, okay? So I go look at my pictures, and I look for X, and we see that X shows up in this picture on the right, right? So X is representing that segment there. So in order to find X, I need to figure out what 2x minus 3 needs to be equal to, right? If I look at my picture, it's a segment. So I got to find the segment over here that it's equal to. Well, this is the way you do it. Look at GH, being the last two segments, or last 2 points there, to create that name, right? So when I look at this name over here, what 2 points should I be looking at?
L
and M. So that tells us that GH and LM were corresponding parts. And if they came from congruent polygons, then those corresponding parts are congruent, right? Okay, so GH has to be congruent to LM, and I look at LM over here, and it's that 8, right? So you see the equation that I can make here to solve for X? 2x minus 3 equals 8. What a lot of people will do with this problem, the people that get it wrong, is that they'll say, well, this is 2x minus 3, but I don't know what M is. And what they did there is they tried to compare right to right, bottom to bottom, left to left, top to top. And you can't always do that. You see that?
Yeah.
Okay. So now if I wanted to, so that you can solve that. All right. But what if I want to find Y? I look at my problem, try to find where Y is. Where's Y at?
It's N. 72.
Okay, so it's trying to, it's an angle, right? That's what you're telling me. 7y plus 9 is representing angle E. So I got to figure out what angle E would be the same as. So, yeah, you told me E is the first letter there, N is the first letter there. So now I come over and find N.
So you do 72 minus 9 divided by 7.
Yep. And that gives you what?
6.
6. Nope.
I don't know.
72 minus 9 is 63, right?
Oh,
What's 63 divided by 7?
5.
Give me 9, right? Y ends up being 9. X ended up being 11 over 2 or 5.5. Okay. But do you see the practice of having to be able to know what this means here?
Yeah.
Okay. This is a very hard problem to do if I don't have that congruency statement. All right. Somebody earlier in the day wanted to do this. I asked them, what does 7y plus 9 equal? And they told me 87.
Oh.
What did they do?
They took it to the wrong angle.
But why?
Left, left.
Yeah, they went bottom left, and you cannot do that and be accurate every single time.
Who was it?
All right.
Who Oh, we can go back.
Don't worry about
Who
it. Let's see here. This is another thing they'll do. Here's another thing that they'll do. They'll give me information like this. They'll give me a congruency statement, and then they'll tell me like N M is equal to 13, and let's say, let's do that. They'll give me that information. Okay? There's 3 things up there, right? And I can maybe get the right answer just by happenstance by just picking out 2 and setting them equal to each other, right?
Yep.
Hopefully we know 8 and 13 probably should be set equal to each other, right?
Yep.
So then I could go 50-50, 2x minus 3 equals 8, or 2x minus 3 equals 13, right?
And
G4. G8, that's an H. I'm sorry. Alright? So they don't give me a picture. All they do is give me this thing here. And I got to be able to take 2 of these things down here and relate them. Well, what do? I take GH, and that relates to LM, right?
Yes.
Well, did I go through here? Okay. Can I create an equation using that information? Yeah. Okay. The people that said, maybe I take 2x minus 3 and set it equal to 13. The reason you can't do that is because NM is the first and last letter over here, and GH are the last 2 letters here. So that tells you that 2x minus 3 should not be the same as 13. So they could give you the picture, but there are times where they don't give you the picture. Okay? And a lot of times they don't give you the picture.
Was that right?
There's some other things on this PowerPoint that I want you guys to do on your own. Look at on your own. We've already seen them once. We'll see them again eventually. But one of them is the third angle theorem, which is the next slide, I believe. Next two slides, okay, just different ways of writing it or showing it. So make sure you're comfortable with that. We talked about that. If I have two angles in one triangle, that up to 100. And I got two angles in another triangle, that up to 100. What do I know about the third angle? They're both what? They're both 80, right?
Yeah.
So they're equal, they're congruent. And really, I said that maybe incorrectly, not necessarily that they both out to 100 initially, but
What's the max?
but maybe angle A up there is 50. Maybe angle B up there is 30. Angle D then would be 50, and angle E would be 30 as well, right?
Is it 360?
So in both those, I have 100 left over for C and F. 180, the total is 180 for triangles.
No, I know for triangles. I'm talking about circles. 360.
All right, so that's
Let me talk.
the
I'm talking about for like.